In section 3.5, we'll review our derivatives of trig functions. Of course, you have to know these from memory. These are important. Hopefully, you can remember most, if not all, of these. So I'm going to do the white ones first, and then we'll see the pattern for the yellow ones. So the derivative of sine is cosine. The derivative of tangent is secant squared. The derivative of secant is secant x tangent x. And then you kind of get 2 for 1s, because if you remember the pattern, once you know these, then the derivative of cosine will be the negative of sine. The derivative of cosine will be the negative cosecant squared x, and the derivative of cosecant will be a negative cosecant x cotangent x. So not a ton of memorization, but you definitely need to know those. We can still use our product and quotient rules with our trig functions. So for the x squared sine x, we can do our product rule and say we get the first x squared times the derivative of the second cosine x plus the second sine x times the derivative of the first, which will be 2x. So there's our derivative there. And for g, using our quotient rule, we can say g prime of x is the denominator, 1 plus sine x times the derivative of the numerator, which is a negative sine x, minus the numerator, cosine x, times the derivative of the denominator, which is cosine x, all over the denominator, 1 plus sine x, quantity squared. We can do a little bit of cleanup here. So if we distribute that, we'll get a negative sine x, and then a minus sine squared x. We'll get a minus cosine squared x, and that will all be over. I don't think we want to try to do anything with the 1 plus sine x quantity squared, but just leave that well enough alone. If you squint at that numerator a little bit, you can see that you can actually factor a negative out of that minus sine squared minus cosine squared, which will leave us with our favorite trig identity, sine squared plus cosine squared, which is just 1. So that will make that 1 minus sine x all over 1 plus sine x squared. And we better stop there. So the particle motion, we talked about this on the last video. So we said that we'll just add a little bit more to it. So S of t is position, S prime of t is known as velocity, S double prime of t is known as acceleration, and there's actually a third derivative there that's known as the jerk. J of t is the derivative of acceleration, or the second derivative of velocity. We don't see it very often, but at least if it does come up, you will have heard of it before. So if we say f of x is cosecant x, we can find the second derivative. So the first derivative is going to be, for cosecant, is going to be a negative cosecant x cotangent x. And now to get the second derivative, we're going to have to use a product rule. So we'll take the first, the negative cosecant x, times the derivative of cotangent, which is a negative cosecant squared, plus the second, the cotangent x, times the derivative of a negative cosecant, and cosecant is negative cosecant cotangent, so the negative will make that be a positive cosecant x cotangent x. So I think we can clean up a little bit. The first negative cosecant times negative cosecant squared is going to be a positive cosecant cubed x, and then we'll get a plus, and it looks like a cosecant x, and then we'll get a cotangent squared x out of that. Okay, well, I think that's pretty much it for our trig functions. Hopefully this is just a little bit of review.